All right, everyone, let's talk hail size and how does hail even form and why is it even important when we're forecasting the weather. You know, we'll talk about a storm with pea-size hail or dime-size hail, but then you get to the golf ball and quarter-size hail, and that's when we get more concerned. And there's a reason, and it's all because of the updraft and the downdraft. Strong thunderstorms, they contain a strong updraft, and of course, they'll have a strong downdraft as well. And that's really what keeps everything going. And then there's rotation going inside of these storms. And sometimes on the radar, especially as we get kind of past our peak tornado season, as we get later into May and on into June and over the summer months, we'll see rotation, but it'll be broad rotation, and it's in the upper level part of the storms, and that's where the hail is being formed. What's happening is you get this, what's called a condensation nuclei. It can be dust, and sometimes it can be like small frogs, things like that. And believe it or not, that has happened before. What happens is that hailstone has to have something to collect around. And once it does, the raindrops carry it into the colder part of the atmosphere. So as we get to a certain point here, the atmosphere is freezing inside of the thunderstorms. And then we get these hailstones forming, and they freeze into the small hailstones. And you can actually cut a hailstone in half if you're careful, kind of like a tree, and it will have rings in it. It will be like milky white and clear, and that's how you can tell how many times that's been through that freezing layer. And sometimes that hail gets above the freezing layer, and it's called supercooled. And we look at that with what's called the VIL value, the vertically integrated liquid. It tells us a lot when we get to looking at hailstones. The hail's carried up and down just like juggling. If you've ever taken like a hair dryer and you put a ping pong ball on top of it, it kind of just floats there and goes up and down. So the reason it stays aloft here is because the updraft can be so strong, and we'll talk about that in a second, that it keeps it going up and down. But once that hailstone gets too big for the updraft, they begin to fall. So sometimes when you see on the algorithm on the radar, it'll say this storm contains 2-inch size diameter hail. A lot of times that's aloft, and some of that hail does melt as it's falling. So the hailstones grow by colliding with the supercooled droplets, and it just adds that second layer on it as it goes up and down through the storm. And of course, it's these bigger storms that produce quite a bit of hail. Now sometimes a few weeks ago, and sometimes you'll get these pea-size hailstorms. These are elevated storms, and they form more because the air is even colder as you go up, and it's not necessarily a severe storm. You just get hail. Not to be confused with sleet. That's a totally different phenomena and worth a different video in and of itself. So the hailstones fall when they're heavy enough, when that updraft begins to weaken. So this can happen for two reasons. One, the hailstones are just severe hail, and it just can't support it because the updraft would have to be ridiculously high to support it, or two, the storm's beginning to collapse. Now sometimes we find before tornado genesis, we get these hail shafts that will actually collapse. And what that does is it sends out this really cold air, and it interacts with the warmer air ahead of it, where we get this rotation, and that can actually increase. It creates what's called a rear flank downdraft, but that's more in the dynamics of developing tornadoes. We've kind of already covered that in other videos. So the hail's carried up and down. The hail stones grow again by the water droplets. They collide within the cloud, and sometimes this collision creates the friction, and you can get lightning out there too by different charged particles. But the hailstones fall again when they're too heavy. They can't be supported by the updraft. So as far as hailstones go, and why are they important? We get 1/4-inch hail. It's not severe. It's a garden variety thunderstorm can produce those sometimes. Then when you get to dime and penny size hail, it gets more interesting, of course. Nickel size hail is still under severe. Severe, they changed the criteria. Now it is 1-inch diameter hail, so that's quarter. And the best way to measure hail when you're giving a hailstone report is to give it in coin size, and then maybe like ping pong, golf ball, tennis ball. We have had softball size hail before. And so in fact, a few years ago down in Coleman, we had hailstones bigger than my fist here. That's a little bigger than softball or so. And it was crashing through roofs in the downtown area there in Coleman. So very dangerous there. When you start to get above this quarter-size hail, the other reason it's dangerous, quarters start to do damage to your shingles, to your automobiles, trucks, things like that. But then once you get up to tennis ball, and a lot of times you'll get storms that just produce a few isolated tennis ball size hail, but sometimes, in fact, my experience with one in Kansas, every hailstone was baseball size. It was just an incredible hailstorm, and you had to worry about the roads being covered with hail. In fact, they had to bring snow plows out to remove all the hail. So again, quarter size is considered to be severe. You get to softball size, that's 4-inch hail. Typically around here, we can get quarter, ping pong, maybe golf ball. It takes a pretty significant storm to produce the tennis ball size hail. So let's talk about why the hail size is important when it comes to severe, not only just due to damage, that's because of the updraft speed of the storm, and it can be pretty violent. It takes a 103-mile-an-hour wind going straight vertical into the storm to produce softball size hail. And again, what comes up must come down, right? So that's how we kind of get to the quarter size hail. A 49-mile-an-hour updraft can actually lead to severe wind gusts at the surface close to 60 miles per hour. So again, remember when you send those reports to us as we go through the spring months, of course, we're going to see more and more in the way of severe weather. Here in March, we are getting a slight break. But again, our peak tornado season, severe weather season month is going to be April. And that is right around the corner, depending on when you're watching this video. Thank you.